But in another way, I'm also taking you on a journey where I think that we have been hearing quite a lot on climate change from two angles. One from the physical models, that how we think that climate change is going to affect our environment, and on the other side of the human environment and how those changes are going to reflect in what people do when that happens. I'm going to take you somewhere in between. So I'm going to use what is happening to the ecosystems from which those people are being affected. In this case, I'm looking at a marine ecosystem, coral reefs. It's well known for rich diversity, biodiversity, for production that sustains many communities along the coast of East and Southern Africa, because it provides these communities with a series of services, most obviously fisheries. Many people that their main sustainable source of food is fisheries. Then other services that are less common but also are important are the coastal protection provided by the reef structure that diminish the force of waves on the coast. Tourism as a secondary economic activity that is bringing money in many of these settlements as well as beach nourishment, providing sediment for other activities such as algal aquaculture, and as a sense of cultural identity, because that's what historically these settlements have relied on. Fisheries as the most important maybe ecosystem service in this case shows trends of increased number of fishermen along the coastline, increases in the number of places where fishing is landed, fish is landed, trends of less catch and less catch per fisherman. And given that this scenario of communities that are very relying on this particular service, we look at what is the situation of these reefs and what are the main threats for these environments, such as overfishing, pollution, other activities of fishing that are more destructive and related to climate change, bleaching, acidification. I'm going to go just in a bit more detail into the acknowledged most common threat for these reefs, which is going to be coral bleaching. This is, sorry. A coral reef when bleaches because the temperature goes above a certain threshold. This is what it looks like. It loses its color. And the long-term effects of this is that with increased temperature, the structure of the reef starts to degrade after continuous bleaching and ends in having no structure at all. The fish leave what was the reef before, and then that translates in no fisheries. Now this is what the projections of climate change impacts are looking for when they are applied to coral reefs. In terms of, these are projections on using the temperature increases, what percentage of the reefs are going to be suffering from climate change, from coral bleaching with the different models, no? So we're just saying that by 2040, more than 50% of the reefs are going to be bleached on every year. That's the projection for the average models. So what happens with this coral bleaching? What happens is that some of the components of that form the ecosystem, from fish to algae to corals, they are affected differently by the bleaching. Some of them, the corals, obviously, many of them die and start recovering slowly. The algae take over in their place, and that has cascading effects on the other groups. That is because there is a complex interrelations between the different components of the ecosystem. And these negative and positive feedbacks end up in different effects for the top components of the system, which are the ones who are targeted by the fisheries. One part of our research has seen that the different types of gear that are used by different communities or at different times of the year, they affect the different types of fish differently. So there's some gears like traps catch a higher proportion of the herbivorous fish, whereas lines, for instance, get a greater share of the piscivores. This, of course, has effects on the system, how increasing or decreasing certain types of fishing gear balances or unbalances the ecosystem. So this was a motivation for building a computer simulation model of this whole ecosystem that would allow us try to represent what we know about the ecology and the interactions between the different components of the ecosystem, so that we can use this as a platform on which we would like to ask questions. What is going to happen if we do this? What will happen if climate change does that? No? So what we took is a integrated food web composed of 27 functional groups, about 11 types of fish and different types of algae, corals, invertebrates, detrital matter. And we also integrated this with what is on the sea floor, how the different types of algae and coral change when there are events like the coral bleaching. And integrating also with how the different detritus that moves through the system collaborates to developing certain pathways like the detritivory pathway, which is a very important complement in coral reefs to the primary production. So with this, we built this model, which we call Caffee. It's a system dynamic model. It's a simulation model that integrates all these processes and permits also to show the effects of 5 artisanal fisheries. These are some details that I won't go into detail now, but we can talk later if anybody is more interested about the details. We have validated this with a long-term data set of fish biomass and invertebrate biomass and the percentages of different types of cover in the reef. And for some of the groups, the fit is pretty good. For other groups, the fit is not so good. But this is also because we're trying here, the data set that we're fitting it is different reefs, so there's also always some differences between the reefs, and you may expect some type of range there between the fits. So with this model, the kind of questions that we have been asking are these: what are the effects of closing a fishery for a certain time of the year, and see what effect it has on the different types of fish. This is, for instance, net fisheries with a certain amount of fishing pressure, like 5 fishermen per square kilometer. After a runtime of, say, 10 years of simulation, you see a reduction in the catch that when with the temporal closures, you get an increase in the catch by the end of the simulation compared to the no closure. What is interesting is that in different types of fisheries, like the net fisheries, line fisheries, effects may differ in the total catch, even though considering that for a certain time of the year there is no catch. So in net fisheries there is a decline at the end. In the line fisheries towards the end is even an increase, even with the closure. We also look at the effects on the coral reef cover and the coral biomass of the different fisheries and the different times of closure. We look at what are the effects of the changing to a different type of gear after bleaching events, and how does that affect in the different combinations of gear change. What are the effects of the changing of the gear on the different functional groups, different types of fish. We also see, well, closing a part of the reef for no fishing has what type of effect it has on the fishing outside that area, and how does that change in different types of fisheries. And one interesting last project that we're working on is how the reaction of or the response of fishermen to a certain disturbance. Like in this case, the fishermen were asked, what would you do if there is a reduction in catch of about 10%, 20 to 50% of what you're catching? What will you do? And the respondents, well, initially for a 10% reduction, most of them just continue doing as they do. But as that reduction increases, there are other responses, like stop fishing, many of them. Some would reduce effort, but some would also increase effort or even change gears to try to get more of the fish. So that's an interesting question that we are addressing. This is a screenshot of what the model runs look like, and we're just seeing how the different options of the fishermen having type of feedback on the system and changing the pressure on the different functional groups. Yeah, just a few points that I would like to make here. Some notice is this model has been designed for coral reef ecosystems, but can be used as a blueprint or a default system for others. In terms of data quality, this kind of modeling is very data dependent. Like there's a lot of processes that have been parameterized there and that are relying on data for particular parameterizations, and good calibrations is going to reduce much of the certainty when we don't know if the data that we are applying is for this particular area or different areas. And yeah, it's a good platform to test particular scenarios and saying, well, how does the different fishing management techniques affect one way or another? Yeah, spatial resolution is now, as it stands, the model is applied to a generic area. Is not especially solved in terms of it can be coupled with physical models, where you're saying circulation models that are affecting a particular place in where the model is being tested. And just last slide for the other type of work that we are doing using this is, well, completing this work on the adaptive fishing, which is what is being piloted now. and then the different management options and their projections of climate scenarios. We're also doing some work based on projections of climate change based on coral costs and how that is going to affect what would we think that is going to do in the projections of the ecosystem. And one last one, which is about well-being trade-offs in the coastal ecosystem services that are being used in these fishing communities. Thank you very much.